we only have one more page, and this page deals with wind and current. These today are easier wind and current problems. Oh wow, that is very hard for you to read, sorry. Tomorrow I'm going to show you wind and current problems that are more difficult, okay? But today we're just going to look at wind, ground, and airspeed, and that's it. Wind, ground, and airspeed. That's all for today. Let's take a look at what we have. A traveler flies from North Carolina, Charlotte, North Carolina, to Los Angeles, California, and at the same time another traveler flies from Los Angeles to Charlotte. The airspeed of each is the same. The ground speeds are shown below. What is the airspeed? What is the wind speed? All right, let's go ahead and try to dig this problem apart. Let's focus on kind of what all of this even means before we begin. Ground speed, maybe we should talk about what ground speed actually is for you. Ground speed is how fast, that looks funny. Ground speed is how fast a plane can go if they were just on the ground, okay? If they were just traveling with no resistance, no air, okay, no wind at all. If they were just on the ground, how fast could this plane go? Airspeed is made up of what the speed should be set at in the air to compensate for the wind. Wind speed is exactly what it sounds like, guys. The wind speed is how fast the wind is. Okay? And that does make a difference when somebody's flying a plane. All right, let's talk about this. I hope that this makes sense. Your airspeed is made up of how fast you can grow on the ground plus or minus how fast the wind is, right? So let's apply this again to the problem. Let's talk about plane number 1. We'll call this guy on the left, we'll call him plane number 1. And then let's talk about plane number 2. We'll call the one on the right plane number 2. Plane number 1. His airspeed is made up of his ground speed. His ground speed, it's very hard for you to read, but his ground speed is 550, which means if there's absolutely no wind, that's how fast he's going. But we know that he is traveling, see how the wind's blowing? See the wind? It's going to the right. He is traveling with the wind, which means the wind is going to push him along. I hope you understand that. The wind is going to push him along. So we got to add the wind to him because the wind is pushing him. Now let's look at plane number 2. His airspeed is made up of his ground speed. If there was nothing happening, he could go 495 miles an hour. So it's made up of his ground speed, but look guys, he's going against the wind. Do you see how he's traveling to the right, but the wind's he's traveling to the left, but the wind's coming to the right? That means we have to take away how fast the wind is going. And they just tell us the wind speed is W, or else we could figure this out right away. Now they did say something in the problem. They said that their airspeed's the same. What that means is that we can use the same variable for them. Okay? Let's go ahead, and I hope you see that elimination works really well in this problem. Do you see it? Why does elimination work really well? Because the W's go away. I saw this a couple of times in class. I'm a little concerned. Do you know what A and A makes? Some of you in class thought A and A makes A. But remember, A and A actually makes 2A. All right? 550 and 495 makes 1045. And now the W's cancel out. Divide each side by 2, and the airspeed for both planes is 522.5 miles per hour. There you go. And that is exactly what we're looking at on this problem. Moving on to the last problem, we have another type of distance resistance problem. You row upstream at 2 miles an hour and you travel the same distance downstream at 5 miles an hour. What would be your rowing speed in still water? What is the speed of the current? Okay, let's take a look at this. The first thing to understand is that you have a speed in the water, okay? Your in water speed is whatever your normal speed would be, and it would be plus or minus whatever the current of the river is, or the river or the stream or whatever it is, okay? So your speed in the water is made up of your normal speed plus or minus whether you're going against or with the current. So let's apply this to the two different situations. I see here that at one point in time you were going 2 miles an hour in the water. We don't know your normal speed, so we can just call that R for rate. Since you're going upstream, that is going to be minus the current. I hope you agree with that, because if you're going upstream, you are fighting the current. And now you go 5 miles an hour if you're going with the current. In other words, you're going downstream. Well, that is your rate and the current, because the current is going to be pushing you along. I hope you guys notice that in this problem, it's set up so nicely for you for elimination. 2 and 5 make 7, R and R makes 2R, and negative C and positive C, well, they cancel out. Divide by 2 and you will see that your rate is 3.5. Now what does that mean? That is your speed if you would just be rowing if there was no current. So let's say that you row 3.5 miles an hour, put an I on there, miles an hour with no current, which is another way of saying or in still water. Okay? They also did want us to solve for the current, though. If you read the problem, it says also what is the speed of the current. Well, let's plug that into 5 equals R plus C. Okay? So that's 5 equals 3.5 plus C. Take away 3.5, and C turns out to be 1.5. So we can say the current is 1.5 miles an hour, and that's fighting with you against, like when you're going upstream, and it's helping you when you're going downstream. So that answers part A. Part B now. Suppose you're rowing in still water is 3 miles an hour. Okay, I'm right here. Suppose you're rowing in water is 3 miles an hour and the current is 4. What happens when you try to row upstream? So you can go 3 miles an hour, but the current is 4 miles an hour. When you go upstream, you're not going to be able to go upstream. Now, why won't you be able to go upstream? Because the current is faster than you. The current that is fighting you, we can say that, not that we encourage fighting, the current that is fighting you, let me move the paper so you can see, is stronger or faster than you are. Alright, when you come in tomorrow, I have a lot more of application problems for you. Don't get too excited.